What's up guys, welcome back to another video here at Chicane, and today we'll be going through speed and density. Please like and subscribe if you haven't already, because I promise you it is this easy. Our learning outcomes for today are to understand what compound measures are, such as speed and density, and to understand the formulas, and also to solve compound measure exam questions. So, what are compound measures? Compound measures are types of a measure that involve two or more different units. They are used to show the rate of an action against another, such as miles per hour or grams per meter cubed. In this lesson, we will focus on solving compound measure exam questions, along with using variable triangles to help. Now, let's have a look at the compound measure we've already looked at, which is speed, distance, and time. As we said before, compound measures are types of measures that involve two or more units, such as meters per second and grams per centimeter cubed. This is an example of a compound measure because distance and time can't be the same unit. So speed is a compound measure because speed can be measured in meters per second, kilometers per hour, and several other forms too. However, distance and time are not compound measures on their own, as they can both be measured in single units, say meters for distance and seconds for time. But speed has to be two of them, which is meters per second. There's another compound measure you need to know about, and this is density. Density is a measure of how much mass an object has per unit volume. Density is a compound measure because mass and volume can't be measured in the same units. Make sure you don't mix up mass and weight, as mass is the amount of matter in an object, such as grams or kilograms, whereas weight is the force of the amount of matter is applied to the earth, and for newtons. When we are given three compound measures that are all corresponding to each other, use a triangle as you did for speed, distance, time, as you can simply replace the measurements, giving you a way to remember density. So density is mass divided by volume, density times volume equals mass, and mass divided by density equals volume. And this is a quick way to remember. Once again, it's that time to have a go at some Math Genie exam questions. Have a go. Pause the video and unpause when you've done. So, in our first question, a sprinter runs a distance of 200 meters in 25 seconds. Work out the average speed for the sprinter. So here we do distance divided by time, which equals speed. So we do 200 divided by 25, which equals 8. So the speed is 8 meters per second. In our second question, a block exerts a force of 120 newtons on the ground. The block has an area of 2 meters squared. Work out the pressure on the ground. As we've been given the equation for pressure, which is force divided by area, we know we do 120 divided by 2, and this will give the pressure. So the pressure equals 60 newtons per meter squared. Now, in our third question, a piece of gold has a mass of 760 grams and a volume of 40 centimeters cubed. Work out the density of the piece of gold. So do mass divided by volume, which is 760 divided by 40 equals our density. So our density is 19 grams per centimeter cubed. In our fourth question, a rock has a mass of 46 grams and a density of 3.5 grams per centimeter cubed. Work out the volume of the rock. So 3.5 would equal 56 divided by the volume. So we do 56 divided by 3.5. This gives us the volume. So the volume is 16 centimeters cubed. When you are given compound measure questions, especially with density, you may be given a common variable for both, such as the mass or the distance if we are dealing with speed. You must read the question first and write out the equations for both sections of the questions. This then allows you to see what is the common variable between them. Say, if I have liquid A and liquid B, I may get given the volume for liquid A and the density for liquid B, and I may be told the mass equals the same. So if I work out mass for liquid A, I can then use the mass for liquid B. You may also be asked to write assumptions with some of your questions, predominantly involving speed. So make sure you read the question to understand if there's any variables that don't change. Here is another exam question for you to have a go at. Have a go, pause the video and unpause when you've done. So, Anthony travels from Newcastle to Manchester at an average speed of 65 miles per hour. The journey takes him 2 hours and 15 minutes. Declan makes the same journey in 2 hours and 35 minutes. Work out Declan's average speed for the journey. As we can see, the common variable here is the distance, because the distance doesn't change because they're going from the same place to the same place. It's just the speed and the time what change. So if we work out the distance, say by using Anthony, we can then use this distance to work out the speed for Declan. So first, let's convert our hours into decimals or into fractions so we can work with them easier, because we can't deal with 15 minutes. So 2 hours 15 minutes is 2 hours 0.25, and 2 hours and 35 minutes is 2 and 7/12. Now, we can work out the distance for Anthony, because we have speed and time for Anthony. So distance for Anthony equals 65 times 2.25, which equals 146.25. Now, as we have the distance, which is the same for both, we then do distance divided by time to get Declan's speed. So do 146.25 divided by 2 and 7/12 to get 56.6 to 1 decimal place. And this is in miles per hour or mph. If you've rounded to 57 or to 2 decimal places, you must state that you have, because the question doesn't specify what to round to. So specify what you're rounding to in your question, because there's a range of marks you can get. So the final answer for us is 56.6 miles per hour. In part B of the question, if Declan took a different route than Anthony, how could this affect your answer in part A? The answer would be, if the distance increased, so would the speed. This is the same if both would decrease, so if the distance decreased, the speed would also decrease, as the time hasn't changed. So the time in both Declan and Anthony got to Manchester from Newcastle hasn't changed in the question, so the distance increases, therefore the speed would also increase. Now it's time to have a go at some of the hardest exam questions you'll probably be asked on speed and density and compound measures. Have a go, pause the video and unpause when you've done. So, in our first question, liquid A has a density of 1.2 grams per centimetre cubed, and 150 centimetre cubes of liquid A is mixed with some of liquid B to make liquid C. Liquid C has a mass of 120 grams and a density of 1.12 grams per centimetre cubed. Find the density of liquid B. So what we need to do is find the mass of liquid A and the volume of liquid C. So we can find the mass of liquid B by doing the mass of C minus A, and the volume of B by doing C minus A. So, liquid A, for the mass, is density times volume. So we do 1.2 times 150, we get the mass of liquid A, which is 180 grams. For liquid C, for the volume, we do mass divided by the density. So we do 210 divided by 1.12 to get the volume of 187.5 centimetre cubed. Now, for liquid B mass, we do 210 minus 180 to get 30 grams. For liquid B volume, we do 187.5 minus 150, which equals 37.5 centimetres cubed. For liquid B density, we do mass divided by volume, so the density of liquid B is 30 divided by 37.5, which is 0.8 grams per centimetre cubed. So our final answer is 0.8. So, in our second question, 100 millilitres of liquid A and 200 millilitres of liquid B are mixed together to make liquid C. Liquid A has a density of 0.7 grams per milliliter and liquid B has a density of 1.1 grams per milliliter. Work out the density of liquid C. As we've got the volume for both liquid A and liquid B, we simply add them together and we do the total mass, which we need to work out, divided by the total volume to find out the density of liquid C. For the mass of liquid A, we do 0.7 times 100 to get 70, and for the mass of liquid B, we do 1.1 times 200 to get 220. Now, we add 70 and 220, and then divide that by 100 plus 200. So our density for liquid C is 290 divided by 300. That is 0.96 carrying on, or 29 divided by 30. You'll get the mark regardless of the form you write it, as long as they're equal to each other and correct. So the final answer is 29 divided by 30 grams per milliliter, or 0.96 recurring. And that, ladies and gentlemen, is the end of today's lesson. I did say it was that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I'll see you in the next one.